First lesson here, section 1, and we're actually going to break section 1 up into 2 parts. So our next video will also be section 1, and it's on functions and continuity. And so we're going to get a baseline of the vocab and a baseline of functions today and continuity today, and then we'll get into some more notation stuff when we get to the next video. And so first, the book reveal here assumes that you already know what a function is. And basically, they're going to really simplify the definition of a function more than I would prefer them to. They're going to say a function is anything where you put an input in and get an output out. All right? And a base way you've done this in math class is this ordered pair over here. And hopefully you remember, and if not, make a note of it in your notebook. And please, please, please be taking notes. Please get a notebook out and be taking notes right now. But ordered pair is always x first and then y second. And so that's x is your input, y is your output. And then they give an example here. It says, suppose you record the number of volunteer hours you need to complete to graduate. All right, so your first semester in school, you're a brand new student. You have to do 40 hours before you graduate. Some schools actually do this. All right, you did 4 hours that first semester, so the second semester you're in school, you only have 36 left to go, and so forth and so on until right before you're graduating. You have no hours, you're done. You can take it easy there your senior year. Right? Also, I said please, please, please take notes, but don't write down every little thing. Please know what a function is. Please know what the domain and range are. It's why they're highlighted here, and I'll talk about things in each slide what are the main things. So please know and make a note. The domain is the x values and range is the y values. And so when I'm looking here, the domain are the numbers 1, 2, 3, 4, 5, 6, 7, 8. And they put them in brackets because that means it's the set. So domain is the set, and you could write it like that. You could write it in ascending order or descending order. That really doesn't matter. Usually a mathematician will put it in order of some kind. So we probably want it to be in order, but I don't care if we start with 8 and went down to 1, or if we start with 1 and went up to 8. Same thing with the range here. They went in the order you saw it, so they went in descending order. But I would probably write that as 0, 3, 10, 16, 18, 24, 36, 40. It's just the way I tend to flip it always in my head when I'm writing the range. I put it in brackets for the set. The range is the y values. Also, if anything repeats, you're just writing what values are there. So let's say the person didn't do any hours the first 3 times. It was 40, 40, 40. You would only write 40 down here once. You're just saying that it happens. You're not saying how many times it happens. They got a graph over here, and that's where those numbers are for that point. So domain and range, it's really what you need to know from this slide. The next vocabulary term is a one-to-one function. For our class, what is a one-to-one function? You know it's a one-to-one function if the domain doesn't repeat. All right? If the domain doesn't repeat. So when you're looking at a list of ordered pairs, if there's one of the x numbers repeats, you know it's not one-to-one. Another way to do that, if you're looking at a graph, is just does it pass the vertical line test? And so this is a pass. Anywhere that you can draw a vertical line, it only crosses that graph one time. Here, I could draw a vertical line out here that would only hit it once, or out here that would only hit it once. But if at any point you could draw a vertical line that hits it more than once, then that's a fail. All right, and so it is a one-to-one function. Pass is not a one-to-one function. Fail. The next word we're going to go to is onto. Again, onto now can get very, very complicated. Onto function. You're going to have to be able to tell me whether something is or isn't onto. And I want to simplify it for the purposes of our Algebra 2 class. Codomain. Codomain is something for those of you that are taking this class because the state of Michigan forces you to, and you're never going to go on to advanced math. Codomain is not going to be super important to you ever, ever, ever. The most common codomain is the codomain of all reals. All right? And so for our class, we're only going to give you a problem where it's onto if it's also a range of all reals. It says the codomain and the range are the same. So really all you have to worry about is the range all real? So when I ask you, is it onto, in your question for yourself, the question to ask yourself in the brain is the range all reals? By the way, this little symbol here, if you don't already know, I call it the double bar R. That symbol means all real. So it's a time save when you're writing out domain and range, and it's everything. It goes up forever, it goes down forever. All right. So the range is all reals. So is it onto? Is the range all reals? Again, if it could be a straight line this way, all right. But if it ends going one direction and ends on the other side going the other direction, or begins, you could say, going one direction, ends going the other direction, that would be all reals for the range, all right, up and down wise. And then you're going to be, yep, it is onto. And so for this one, let's talk first about the domain. The domain is the x values. Does this graph go left forever? Well, it's going left very slowly. It's going down way faster than it's going left, right? But it is going more and more and more and more and more left slowly but surely. Same thing as it goes right. It's going down faster than it's going right, but it is going further and further and further right as it goes. And so it's for going left forever. It's going right forever. And so therefore the range is everything, all real numbers. Now you can feel free to write out all reals and not remember that double bar R, but it's just a time save. You could also write it goes from negative infinity all the way to positive infinity. All right. And I mean, that's just, I don't know why you would take the time to write it that way, but that's not wrong. And it says it goes everywhere. Now, how about the range? Does it go up and down forever? Because remember, x-axis is the domain, y-axis is the range. Well, it goes down forever. It's going down fast. It's going to go down quickly and forever and ever and ever. It, however, does not go up forever. It stops right there. Because we're talking about the range, we're talking about up, down. So what is the y up, down, at the highest point it gets to? 0 is the y value right there. So it's going down, so it's everything smaller or equal to 0. And again, it's a set, so I'm going to write it in the little brackets. It's just the easiest way to quickly denote a set. Now, is it 1-to-1? Which for us, remember, is does it pass the vertical line test? Anywhere I draw a vertical line, does it cross it only once? Yes. And so it is going to be 1-to-1. Is it onto? Onto, remember for us, is the range all reals? The domain over here was all reals. The range, though, wasn't. So for us, it is not onto. And therefore, it's not both. And it is 1-to-1, so it's not neither. And so that was bad grammar right there. It is, however, 1-to-1. Now, anytime you get a table, you really got to define what you're looking at. And so we're going to look at this table. We're only going to talk about the United States gold medals in each given year. And so first, I want to define the domain and range. And so if I'm just talking about gold medals, what is the domain and what is the range? Now, some of you might be thinking the domain are these numbers here, but the domain is the year. Based on what year we're talking about, we know how many gold medals are won. So the domain is the input. All right. And so the domain here is the set. And I, again, write things in ascending order. So I'm going to start with 0, 0 and work my way up to 16. You could certainly start with 16 and work your way down to 0, 0. The range then, I'm going to work in ascending. The smallest one is 36. Now, 36 happens twice, but I'm just saying 36 is there at all. And so I don't want to write it twice when I'm writing out the range. 36, 37, and 46 are the range numbers. Is it 1-to-1? Did the domain repeat? The domain does not repeat, so yes, it's 1-to-1. Is the range all reals? No. So for our class, we're going to say it's not onto, which means it's not both and it's not neither. How about this one? And we're not going to worry about domain and range here. Let's just worry about onto or one-to-one or both or neither. So vertical line test. Does it pass it? Yep. So it is one-to-one. Is the range all reals? Well, it goes up forever, but as it goes down, it kind of levels out. So it doesn't go down forever. And so it's not onto. It is just one-to-one. Same thing here. Passes the vertical line test. So it's one-to-one. It goes down forever, but it doesn't go up forever. So it's not onto. It's just one-to-one. I made some quirky examples here. This is a graph that on the left here that probably is not very realistic to a graph you'll ever deal with in class. But it goes up and down forever. However, it fails the vertical line test. And so for us, this would just be onto. This one over here is not the world's greatest example. All right. If you said it was onto, I would say, yep. But also it looks like almost that levels out. And you could say maybe that levels out. And so maybe, maybe it's neither. It's not the world's greatest example. But if it does go up forever and down forever, it's slowly but surely going up and down, then it would be onto. Right? Discrete and continuous. So the first word is discrete here. That's the first word. Maybe you should write down your notes. That's probably the newer word for you. So discrete. All right. Discrete is a graph like this one. A discrete just is like a scatter plot of points. Random points across a plane. Discrete. Right? Continuous means that the whole, in every direction you go, left or right, as you work forward or backwards, the graph is unbroken. It's just it's continuous. And so that's the other word you need to know. And that one is the first example here. And I don't want to abbreviate continuous. Right? This one here has a hole in it. And so really proper grammar is just discontinuous, right? It's not continuous. It's continuous for everything but that hole, right? It's going, stop, hole, going. So it's everything but the hole. All right, but for us, we're just going to say it's either continuous or it's discrete or it's neither. So whole bunch of random points, discrete, truly a continuous graph, continuous, whole, neither. The one that gets tricky for some people is square root graph, and when we get to that one, we'll talk about it. So is this one discrete or continuous? Or neither? This one kind of tricked me earlier. I thought that was a hole, and then somebody in class pointed out yesterday that it was just the O for the origin. Heck yeah, they're right. So it's a continuous graph. Right. Now, when you don't have a graph to look at, it can still be discrete, continuous, or neither. Right. And so I'm going to make a little table here, or a graph rather, to go with this to help us think through it. All right. And so we could buy 1 pound of coffee or 2 pounds of coffee or 3 pounds of coffee or 4 pounds of coffee. Well, maybe not 4, so we'll just skip right to 5. All right. And then if I buy 1 pound, it's $8. 2 pounds is $16, and then 20 and 22 and 35. And so I'm going to put some points on here. And so it says up to 2 pounds, $8 a pound. And so I don't know why you would walk in and ask them how much 0 pounds of coffee is, but 0 pounds of coffee would be $0. And assuming they'll sell you any amount of ounces from 0 all the way up to 2, it's just going to be a straight line at $8 a pound. All right. Now, once you get to 2, though, they're no longer going to pour it into a bag. At 2, they're going to say, hey, we're going to give you a deal. You can buy 2.5 for $20. Or you can buy 3 for $22. Or you can buy 5 for $35. You can get the best deal. And so the beginning part of the graph is continuous. The end part of the graph is discrete, which ultimately means the entire graph is neither. Now, this problem also says, then state the domain and range. So let's talk about the domain. The domain is the set. Well, it went from 0 to 2, pretty continuous. So I'm going to say it goes from 0 to 2. But then it jumps to just random points, 2.5, 3, and 5. The range, same kind of thing happened. You started at $0. You went all the way up to 2 pounds, which was $16. But after that, you were just at these random points, 20, 22, and 35. And so that would be the domain and range for this problem. If you're doing the problems out of the book, 1 through 4, please ignore codomain. All right, just do domain and range. And I think the question says domain and range, is it onto? All right, 7 through 13, do what they ask. I think on 13 it asks, is it discrete or continuous? But 13 also asks you to define the domain and range. So go ahead and work on that and have a good day.